Okay, let's have a look at this. So we need to get dy dt. Here's the rule for e to the ax differentiates to e to the ax. So it's just like the a comes down. The symbol x, when we're differentiating here with respect to the symbol t, isn't it? But it's the same process. So part A, dy dt then is equal to, the minus 2 comes down, minus 8 e to the minus 2t. Then the minus next term, run along the row, plus 20, isn't it? Minus 5t. So that's dy dt, now d2y by dt squared. So the minus 2 comes down to make plus 16. And then the minus 5, so it's minus 100, isn't it? So that's part A. Part B, y and dy dt when t is 0. T equals 0, y is equal to, put 0 in here, e to the 0 is 1, so that's 4, and e to the 0 is 1, so it's 4 take 4, and dy dt, so dy dt then, so put it in here, e to the 0 is 1, minus 8, e to the 0 is 1, plus 20 is 12, so that's B. Part C then, dy dt equals 0, so when does this equal 0? So minus 8 e to the minus 2t plus 20 e to the minus 5t. That's dy dt then, equals 0 when... Okay, so let's move the 8 over here. So we've got 20 e to the minus 5t equals, and move this across the equals 8 e to the 2t, and then we can e to the minus 2t. Now what we'll do is we'll move the 8 down there, so 20 over 8 equals, and we'll move the e to the minus 2t underneath, the e to the minus 5t down to divide as well. Okay, now we'll use properties of indices. 20 over 8 is like the same as 10 over 4 or 5 over 2, so that's 2.5. With indices, divide you minus top take bottom, so it's e minus 2t minus minus 5t is plus 5t. So minus 2t plus 5t is 3t. Now we'll take logs, write this index or equation in the form of logs, so the e drops down to be the base number. So ln 2.5 then, log e of that is equal to 3t. And now lastly, we can just get what t is. Move the 3 from times to divide and write it down from right to left. 1/3 ln 2.5. Let's type that in the calculator. 1 divided by 3 times the natural logarithm of 2.5. 0.305. So that was part C. T was equal to 0.305 as a turning point. We need the coordinate of the turn, see whether it's a max or min, isn't it? Is it a max or min? Okay, so we need to put in this value into the second derivative, and we'll also need the coordinate, won't we? So let's get the second derivative first. So d2y dt squared then is equal to 16, and put this value in here. So I'm just going to type that in the calculator. Let's do that then. So it's 16 times e to the minus 2 times 0.305. ground level, minus 100 times e to the minus 5 times 0.305. Okay, so that's the value. Minus 13, which is negative 0.0606, which is less than 0, so at this when dy dx dt is 0, the second derivative is negative, so a max. That's the bookwork, it's a maximum. Now at t equals 3.5 then, 0.305 rather, what does y equal? Let's find the turning point itself. Where's y? Y will be up above, and we're putting in 0.305. So there's y at the top, so I'll just put it in here. So what is it then? It's this 4 times e to the minus 2t, 4 times e to the minus 2 times 0.305 minus 4 times e to the minus 5t times 0.305 equals 1.30. So that's 1.305 or 1.30. I'm just gonna, I should put 1. I've done it to 3dp here, haven't we? So let's have a look back what it was. 1.303 rather. Okay, so that's a turning point. 0.305, 1.303. Okay, that's C. Now D. Where is the point of inflection? Now inflection can either mean a turning point here, where dy dx is 0, or an inflection can go like this, it snakes back on itself. At a point of inflection, the second derivative is 0. So let's find that point of inflection then. Just get the second derivative, let it equal 0. Here it is here, so it's another bit of algebra. Okay, let's have a go at it then. This is D. So here we've got 16. So let's do the algebra for this. Minus 100 e to the minus 5t equals 0. Move this across the equals. Now I'm going to move this e to the minus 5t down. Leave the e to the minus 2t where it is. Move the e to the minus 5t down, just as we did before. And that will equal the 100 that we leave as is, and we'll move the 16 down from times to divide. This here, divide your minus top take bottom with the rules for indices, so you end up with minus 2t minus 5t, which is plus, giving e to the 3t. 100 over 60 is 50 over 8, which is 25 over 4. Okay, and that's 6.25. Tap it in the calculator if you need to. So now let's take the log form of that indecimal equation. So the e swings down, 3t is equal to ln 6.25, and t is equal to a third of that. So what does that equal? 1 divided by 3 times the natural logarithm of 6.25. 0.61 is the value. Okay, I've done it to 2dp there. And what's the y value? Because it's the point of inflection, so we need the coordinate. Y is equal to, now what have we got here? The t value is 0.61, and we're putting it into y. Minus 4 times e to the minus 2 times the 0.61, wasn't it? Minus 4 times e to the minus 5 times the 0.61. Minus 0.75. Let me just check. Oh, I've got answer. Let's just go back. I think I've left the answer in. See, I don't want the answer from before. And I'm going to double check that as well. Let's go back and double check that. Minus 4 e to the minus 2 times 0.61 minus 4 e to the minus 5 times 0.61. That looks okay. Yeah, that looks okay. Equals minus 1.37, which I don't know if it is actually. Let me just double check that. Yeah, just looking at it a bit more closely, I can see that first minus was wrong as well. It was answer minus, wasn't it? It's just 4 rather. 0.991. Okay, so 0.99 then. So that's part D. Now part E. Now, okay, so E, y equals what as t tends to infinity. So if we look at this, I'll put it up here. There's a bit of room up here. As t tends to infinity, the e to the minus x curve looks like that. Here's the e to the minus x curve. So as x tends to infinity, e to the value as x tends to infinity tends to 0. So these both tend to 0. So it's 0 minus 0. Okay, so now we should be able to sketch the curve. I'm not going to sketch it in this section, but all the information is here. Turning points, coordinates, maximums, and the inflection, and where it tends to at infinity. But I'm going to leave off doing that because it's too onerous a question, I think. And we'll focus on the calculus.